So once again, on these, usually the fastest way to graph is to find the vertex, find the axis of symmetry, and then plot another point. So if I'm finding my vertex, I'll go through this fairly quickly here. I know that the vertex has the coordinates x and y, and what I'd like to do is find where this turning point is. Okay, so I know that the x coordinate is going to be equal to negative b over 2a. Everybody can see this okay? Alright, so I should identify what the a, b, and c are. Pardon me for a moment. If we take our a right here, our b right here, and our c, I can calculate the x coordinate. I get negative. In this case, b is positive 6, so I'll get a 6 over 2 times a. Well, in this case, a is 2, so I'll put a 2 there, and I get negative 6 over 4. And if you remember, this fraction reduces to negative 3 halves. Okay, so in this case, I get a fraction. Now, by the time you're in Algebra 2, you shouldn't be afraid of fractions. Let's hope you're not. And so, the x-coordinate, yeah.
So you know how it's 2x squared, you know?
Yeah.
On the 2a, you know how it is? You don't need to square the 2x first and then times it by 2?
No, remember, exponents go first. Yeah. Please excuse my dear Aunt Sally. You got to do exponents first before you do multiplications. So you always deal with this part first and then multiply by 2.
That's right, so it's not 2 times 2 is 4 and then times it by 2?
Well, right now we're doing this calculation.
Wait, we're starting with that missing?
Yeah. We're starting with this calculation. The b is 6, the a is 2. So we're finding the x-coordinate. That's where the vertex is going to be. Okay? So what we need to do now is find the y-coordinate of the vertex. So what we know so far is that there's 3 halves here. Okay, 3 halves. Well, what we need to do is put the 3 halves in here. So that's a little bit tricky. So I'm going to write it up here. I need some room. Erase some stuff here. Okay, so y is equal to what? It's equal to 2 times 3 halves, and then we square that, and then we add that to 6 times 3 halves. In this case, we have, well, 3 halves here, and then we're going to, oh, we need to make this negative, right? This is a negative 3 halves. It's negative right here. Okay, and then we're going to add 3. Now, if this is complicated for you, you could always put this all in a calculator and see what happens. And it simplifies. Okay? Well, in any event, if I plug this in my calculator, let me just do that real quick. Save us some time here. Alright, so if I do that, this whole thing is going to be equal to negative 3 halves also. And so I'll have negative 3 halves here. Well, that's an interesting vertex. So what it means is my vertex, that's basically 3 halves is the same thing as negative 1.5, right? So it's negative 1.5 comma negative 1.5. Okay? So 1.5 would be right about here, 1.5 is right about there, so that puts my vertex right there. Does that make sense? Okay, so raise this up a little bit. And so I have an axis of symmetry now. It's going right down the middle here. Okay, so you might have some fractions to deal with on the homework. So there's my vertex. And right here is my axis of symmetry. Okay, now the equation of this axis of symmetry we were talking about it's going to be x is equal to negative 3/2. It's really easy to figure out because it's always the x coordinate of the vertex. And see, so there's your axis of symmetry. So now what we want to do is find another point and plug it in here and see what happens. Somewhere that's nearby the axis of symmetry. Maybe we could use x equals 3, or maybe we could use x equals 0. I don't know, I'm tempted to use 0 because that's 1.5 units. So if I use x equals 0, that would be a pretty good choice. I'm going to find out that y is equal to what? It's going to be this equation right up here. So I have 2 times 0 squared plus 6 times 0 plus 3. I think you could all see that that's going to be equal to 3. So when x is equal to 0, y is equal to 3. So there's a new spot, a new point. And that's 1.5 units from my axis of symmetry. So if I go 1.5 units over here, I'm at x equals 3. I can get a mirror image point. And so now I have an idea how this graph goes. It goes down like this, passes through this vertex, turns around, and starts going back upwards this way. Okay? So there you have it. Another example of how to graph these. In this case, the example was a little bit more difficult because the parabola had a vertex that was a fraction. And that might happen. I mean, who cares? Okay, so we did another graph problem. Now let's look at a revenue problem where we might apply. This is an application problem. And I kind of like the application problems, especially when it comes to test days. And so I hope you can handle the application problem. I'm trying to pick a different color here. Maybe I could use white now. Well, the thing I want to talk about is revenue. The revenue function is always equal to some number of items times the price. The P stands for the price, X stands like the number of items you have. So you have like a number of items that you're selling. Like in this case, if you had 20 candy bars, the number of items would be 20. And the price, of course, is what you're charging. And so if you charge $1 per candy bar, and that example, the candy bar example, you'd have 20 times $1, and your revenue would be $20. Okay? Well, here we have a go-kart company, and the go-kart company realizes that about 380 racers per week, that's what they have, and they charge $35 to race. Okay, so those are some of the key facts. Now, naturally, if the race car owner increases the price, he'll probably lose some of his customers. Right? So if he increases the price by $1, there will be 20 more racers per week for every dollar that he reduces the price. So, in other words, if I reduce that price to $34, I gain 20 customers. That sounds good. I get more customers and make more money, right? So, this is an interesting revenue function, and revenue functions this sort might turn out to be a quadratic or parabola type equation. Let's see how that works. So, before I get going too much, we need to define a variable. I'm going to say let x be equal to the number of $1 reductions. Okay, that's my variable. And so what we want to do is write down the revenue function. Now, revenue then, I start out with this here. Remember I said the revenue function is equal to x times p, right? Well, the total amount that we had in the beginning was 380. So if you take like 380 and you multiply it by the amount that you charge, which is the price, 35, this would tell me how much revenue I'm making. Like, I'll just do this real quick to give you an idea. 380 times 35. Wow, that's $13,000. 13,300. Okay, so that's pretty good for a week. I mean, this guy's doing pretty good if he gets that many customers. He's charging a pretty good price, though. And it seems weird that if I reduce this number, like if I go down to $34, how's that going to affect my total revenue? Would I actually make more money?
No.
You're kidding me. You'd think you'd make less, right? But here's the deal. If I do that, I gain 20 customers. So in that case, I have 400 now, you see? And so what I do is multiply this by 400. Now let's see what happens. I'm just experimenting right now. 400 times 34. And now this is equal to 13,600. And so now I've made $300 more per week. So it seems counterintuitive that you lower the price and you actually make more money. But what it means is that you're doing more business. And it's the same is true for McDonald's. Like when they reduce the price on a $6 burger or whatever, they get more people to buy the burger, and then you're making more money. Okay? On the other hand, you do have to hire more employees to make the burgers, right? So it all kind of balances a little bit. But you get the idea here. So this is the equation we got to deal with. So our starting amount was this. And what we do is we gain 20, right? So here's what I want to do. I want to write this. I start out with 380. And remember, every time I reduce this $1, I gain 20. So I'm going to say plus 20x. Okay, does that make sense? That's my new amount. Now, how's my price going? My price is going down by $1 each time, right? So I started out with $35, and I'm subtracting x. You see? Now, you'll notice, let me just get a moment to close the door here. I have to finish this up in about 3 minutes. Okay. When I multiply this out, we will have a quadratic. Now I'm going to go a little bit fast here. I'm going to use my calculator to help me out here a little bit. The revenue function, what's it look like? And you don't have to write any of this down in your notes, but there's an example in your book just like this. If I take 380, multiply, all I'm doing is the FOIL method, right? You guys learned that? All right. Back from Algebra 1. 380 times 35, that's the original 13,300. 13,300. Okay, and then I do this term times this one, this one over here. That gives me minus 380x, and then this one times this one. 20 times 35 gives me 700x. 700x. And now I need my little eraser. I got too much junk over here. Alright. So, and then finally I have this term times this term. Hey, that turns out to be a negative, right? So 20 times negative x is negative 20x squared. Now I'm going to rewrite this so that the x squared term is first. So the revenue function is negative 20x squared. Now I add those two together, right? One of them is positive, one of them is negative. So 700 minus 380. You can do that in your head, right? It's a positive 320x. Huh? Oh, move that up a little bit? Yeah, I can do that. And then plus 13,300. Now, on this particular problem, we want to find the maximum weekly revenue. And that means we need to find the vertex, right? Thank goodness Mr. Russell told me how to find a vertex, right? How do we find the vertex? The x coordinate is equal to what? Negative b over 2a, right? So, in this case, by the way, does this parabola open up or down? It goes down. See, that because of that negative, we know that this parabola goes like this. It's going to go down like that. So that turns out that there is a maximum at some point here. And that's the point we're after. Because that's the point we want to tell the guy, hey, you want to charge this amount of dollars. Alright? So in this case, we'd have negative b. So in this case, we'd have negative 320 over 2 times negative 20. Okay? And so what we'd get is negative 320. I'll go down a little bit further and run out of space. Negative 320 over 40, right? And that's negative 40, right? And so what do we get? 8, right? It's a positive 8. So if I've done my calculations correct, what we want to do is reduce the price by $8. Because remember, X was equal to the number of $1 reductions, right? And we started off with $35, right? So let's just do a calculation real quick. If I've done my math right, the maximum revenue will be when I take 35 and I subtract 8. Okay? And so 35 times 8, excuse me, minus 8, it gives me what, 27? So my revenue then, my new revenue is going to be equal to $27. But notice how many customers did I increase? Notice I get 20 each time. So if I take 20 and multiply it by 8, I just gained 160 customers, right? So 160 plus 380 plus 160 gives me 540. So if I take these two and I multiply it, I get $14,000 and 580. 580. Yeah, that's awful. 14,000. I'll rewrite it here. 14,580. Now take a look. That's quite a bit more than what I was making initially. And so you've asked, where do I use parabolas and stuff? Well, here's a business example where a person is now making almost 1,000 more by applying his knowledge about parabolas. I know the maximum occurs at the vertex. The vertex occurs at negative b over 2a. And that's the calculation we did right there. Okay? So that's an interesting word problem. You're going to have one of these on your study guide. So what I want you to do is work on your study guide. Try to finish up your study guide for homework tonight. Tomorrow will be a free work day. Wednesday we're going to work on the assignment in the book. And that's it for today. We'll see you.